sessions of digital electronics, and today we are going to discuss the universal gates, the concept of universal gates. So as we know that AND gate, NOT gate and OR gate, all these three gates are the basic gates, okay, and then the other class of the gates is what? Derived gates. So in this case, the two gates we are going to use as universal gates. The first one is NAND gate and the second one is NOR gate. And as discussed in the previous videos, we know that NAND gate and NOR gate are the types of derived gates, right? So in this case, using these two gates, we can construct the logic of basic gates, and that's why these two gates are called as universal gates. Okay, that means when we are going to use only NAND gate, then using only NAND gate, we can construct the circuit for AND gate, we can construct the circuit for OR gate, and also we can construct the circuit for NOR gate. Similarly, using NOR gate, we again we can design the circuits for all three basic gates, that is OR, AND and NOR gate. So one by one we are going to discuss here, and in this video particularly I am going to focus on how NAND gate is used to construct the basic logic gates. Okay, so here the first basic gate that we are going to construct is NOT gate. So the first circuit that we are going to discuss here is NOT gate using the universal gate, that is what? NAND. So as we know that, what do you mean by logic gate? Logic gate is a digital circuit which may consist of one or more than one inputs but only one output. Okay. So in that case, here we are going to use the NAND gate to construct the NOR gate, right? So here we have to construct the NOR gate, and also we are going to discuss the truth table of it. So if suppose I am going to take one NAND gate, so if suppose this NAND gate is of two inputs, to construct the NOR gate, what we have to do here is we have to short these two inputs, and only we are going to give the single input. Suppose here I am using A as the input and Y as the output. Then this will be the circuit for NOT gate using NAND. So we will discuss about its truth table now. We know that NOT gate is the only gate which is having single input. Okay. So in this case, the input is named here as A, and what is output? Output is named here as Y. So as in case of single input, it can have only two states, either 0 or either 1. So logically we are going to prove how this circuit is going to perform as a NOT gate. So suppose in first case the value of A is 0, means this 0 will be given to the first input of NAND gate and as well as to the second, because the same thing is applied over here. So both the inputs of NAND gate are 0, 0. So NAND gate is what? It is the complement of AND gate, and we know that in case of AND gate, when the inputs are 0, 0, the output is also 0. But here we are using the NAND logic, so when the inputs are 0, 0, the output is 1 in this case. So for 0 input, we are getting the output as 1, because we know the truth table of NAND gate. Okay. The second case is what? When the input is 1, here you can see the same 1 is applicable to both the inputs of this NAND gate, and then you will find that when both the inputs are high, we know the output of NAND gate is what? It is 0. So in this case we are getting 0. So you can see here, using this logic diagram, we can get the truth table of NOT gate, and that's why this circuit is named as preferably NOT gate. This circuit is known as preferably NOT. Okay. Now we are going to see the construction of second basic gate, that is what can say AND gate. Okay. So now here we can construct the circuit for AND gate. So you know that what is the truth table for AND gate? First of all, we will derive for two input AND gate. we are going to draw the truth table and then we will verify as per the logic diagram. Okay. So two inputs we are going to consider here, A and B, and single output, that is what, Y in this case. So when both the inputs are 0 0, the output of AND gate is 0. When the one input is 0 and the another one is 0, then also the output of AND gate is 0. For this situation also the output of AND gate is 0, and as per the definition of AND gate we know that the output of AND gate is high only when all its inputs are high. So we have to draw the circuit using NAND gate which can verify this truth table. Okay. So in this case we have to take two inputs. So input A is there, input B is there. So in this case what I need to do, I need to connect these two inputs to the NAND gate. Okay, to the NAND gate, and here we have to take the complement of it. So in this case I will connect the NOT gate using NAND to get the complement. So we will verify this truth table for first input. Suppose this is 0, this is 0. We know that this is the NAND gate. So when both the inputs are 0, the output of AND gate is 0, but the output of NAND gate is 1. The output of NAND gate is 1, and it is given here as the input for the second NAND gate. So you can see here when both the inputs are 1, as this circuit is of NOT gate that we have seen previously. So this circuit is of NOT gate. Here it is used as NOT gate. The complement of it will be generated. So we will get 0 here. So when both the inputs are 0, then output we are getting as 0. So this first row is verified. Now we will check for the another condition where A is 0, B is 1. So A is 0, B is 1. This is the NAND gate. So again we can say that NAND gate is the complement of AND gate. So we can get when one input is 0 and another input is 1, the output is 1 here. And in the same case this 1 is given to the inputs of this second NAND gate. So again here we are getting the output as 0. Here again we are getting the output as 0. So second row is verified. Now in case of third row, A is 1 and B is 0. So A is 1, B is 0. So for this case the output of NAND gate is 1. The output of NAND gate is 1. So same 1 is again connected to these two inputs where we are getting the output as 0 as in the previous case. Now we will verify for the last row when both the inputs are 1 1. When both the inputs are 1 1, we know that the output of NAND gate is 0. So here this 0 is applicable to these two inputs of the second NAND gate, and you know that this particular circuit is performing as a NOT. So when both the inputs are 0 0, we are getting the output as 1. So here the last row of the truth table is verified. So you can see that this circuit can be used as a AND gate. So using NAND we have constructed the circuit for AND gate. So this is what the circuit for, you can say that AND gate. Now the third circuit we are going to discuss, that is the third basic gate we are going to discuss here is OR gate using NAND. First of all we will draw the truth table for OR gate. So again here inputs and the second column will be for outputs. Two inputs A and B and the output is 1. The output is 1. So the combinations for input are 0 0, 0 1, 1 0 and 1 1. So in case of OR gate, what is the output? When both the inputs are 0, the output of OR gate is 0. And if any one of the input is 1, the output of OR gate is 1. So for remaining rows, the output will be 1 1 1. Now we are going to verify this truth table and we are going to construct the circuit or the logic diagram for OR gate using NAND gate. So only we are allowed to use NAND gate here. So in this case, what I am going to do here, we are going to take two inputs A and B, and we have to take the complement of A. Again we have to take a complement of B, and then these two outputs we have to combine. At the last stage we the third NAND gate. So this is the first NAND gate, this is the second NAND gate, and this is the third NAND gate. So logically we are going to verify this truth table. So first combination is what? A is 0, B is 0. You got this particular circuit is going to perform as NOT gate. Even this is also going to perform as NOT gate. So you know that when the input for NOT gate is 0, the output will be 1. Input at NOT gate is 0, the output will be 1. So both are 1 1 in this case. But this is the NAND gate, and you know that for the input 1 1, when all the inputs are high, the output of NAND gate will be 0. So that's why the first row is verified. That is when both the inputs are 0, the output is also 0. Now the second case where A is 0, B is 1. A is 0, B is 1. So this is 0, as it is going to perform as a NOT gate, 0 will be complemented over here. So 0 will become 1 in this case, and in this case this 1 will become 0. So its one input is going to become 0, and that's why the NAND gate, in case of NAND gate, you know that for dissimilar inputs the output is high. So again the second row is also verified. When A is 0, B is 1, the output is high. The third situation is A is 1, B is 0. These two NOT gates will produce the complements. So in this case A will become 0 and B will become 1, and that's why the output is high, because this is the NAND gate. So third row is also verified. Now the last situation, when both the inputs are 1 1, the complement of both will be generated. So NOT gates are there, these two, one and NAND gate 1 and NAND gate 2 will generate the complements. So when these two outputs will become 0, and these zeros will be applied to the inputs of third NAND gate, and you know that when both the inputs are 0, the output of NAND gate is 1. The output of NAND gate is 1. So this is the fourth row is verified. So here in this case we can design the basic OR gate using NAND gate. Okay. So for summary we can have a look. So here this is the structure of OR gate. The first structure I will draw again. I will repeat here. A bar. So this is NOT gate, and the third gate that we have designed here is, which is having two inputs A and B, and then the output Y is equal to A dot B. So this is AND gate. Okay. So all these three basic gates we are going to derive using the NAND gate. Okay, using the NAND gate. Right. So in this case the output is equal to A plus B. So these are the equations for outputs. In case of NOT gate, Y will be equal to complement of input. In case of OR gate, Y will be equal to A plus B. And in case of AND gate, Y will be equal to A into B. A dot B, you can say that. Okay. So in this video we have studied the designing of basic logic gates using the universal gate. That is the first universal gate we have taken in this video as NAND gate. So thank you so much for watching this video. Please like the video and share and comment us. Thank you so much.